Okay, so here is our third one for the final. Again, it's partial because it's only exam one material mostly. And here we go. So let me go through the usual moves now, which is this and bringing down the paper. Let's see. There we go. We got it down. Okay, so now this again is Math 105, partial review for the final, and we're up to C. Okay, starting with problem number 1 on C. Here's something we haven't seen before. It's back to factoring, but it's a special situation of back factoring that I see we need to know, and therefore that's why we're doing it. It's when you got all perfect cubes everywhere and you have a plus in between. You don't have a minus in between. So that really wouldn't make a difference. But I mean, it does make a difference, but it's not like the difference between two squares. We're talking about cubes. Now, notice this. 27 is a perfect cube. 3 times 3 times 3 is 27. Y cubed, of course, is a perfect cube. Y times y times y is y cubed. And 64 is a perfect cube. And that is 4 times 4 times 4 is 64, plus a plus in between. So here's what you got to remember. Unfortunately, you got to remember the following thing when you have all perfect cubes. You can take a plus b, and I'll tell you what a and b is in a second. It can turn into this. It turns into this. A plus b times a squared minus ab plus b squared. It's not that long of a deal, but it's still. Now, what's a and b? A is going to be the cube root of the first term. Cube root of the first term is 27. The cube root of 27 is 3. The cube root of y cubed is y. That's a. And b will be the cube root of the second term, which is equal to 4. 4 times 4 times 4 is 64. That's what a and b is going to be concerned. So now is going to be equal to in our case. So now just replace into this that we need to memorize, and that's how you factor perfect cubes. We need to memorize what does a turn into? It's going to be 3y. What's b turn into? It's going to be positive 4. Okay, times, what's a squared? 3y times 3y is 9y squared. What is minus a times b? A times b is 3y times 4 is 12y, and minus a times b is going to be minus 12y. So that's going to be minus 12y. And what's b squared? 4 times 4 is 16. End parentheses, end of problem. We have factored this. We have factored a situation where we have perfect cube, perfect cube, perfect cube with a plus in between. That's what we needed to know for this final. Problem number 2 on C is as follows. What if you have A is equal to 4/7 times B plus C? And the situation they ask you to do, let's again cordon this off. Try to avoid as much confusion as possible. Solve this. Here's the question that they say: solve for C. That's what they want. Solve for C. So we have to isolate C on the left or the right. Okay. First thing that's got to go is the 4/7, the thing that's outside the parentheses. We got to work our way towards that C. It's inside the parentheses, but we got to get the outer shells first. So to get rid of this 4/7, we multiply by its reciprocal, 7/4. Whatever you do to the left, you must do. Whatever you do to the right in this case, you must do to the left. 7/4. What do we accomplish? Bang, 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 and bang, all gone. So the right becomes B plus C, and I don't even need the parentheses anymore. The left becomes 7/4 A. You can either put the up there or in the middle. Whatever you like. It could be up there in the numerator, or it could be in the middle. What are we looking for? We're looking for C. We got one more move, and we're done. Minus B on left, minus B on right, and we are done. We have found C. I'm reading right to left. That's probably not what's going to be on your paper. I'm reading right to left. It's going to be, but the answer is 7/4 A. Either you put it up there or in the middle, minus B this problem is over. Let me get this paper up right now. Okay, let's move it up right now and get everything that we can out of it. Okay. So there is problem number 2 done. Let me go over here, cordon this off, and go on to problem number 3. Problem number 3 is as follows. What if you have x plus 4 squared, let's not make it x, let's make it v, so you're used to different letters. V plus, so you don't see x and y all the time. You might see u, v, s, t, r. V plus 4 squared minus 48 equals 0. It's a quadratic equation. How do I handle it? Here's what I do. I first got to get rid of that plus 48. I'm going after the x, right? The v. So I got to get rid of that minus 48, plus 48 left, plus 48 right. My goal is that v. Got to get rid of the outer layers, as like we said before. This becomes, I still need the parentheses. Don't get rid of the parentheses yet. V plus 4 squared is equal to 48, because this stuff is gone. Now, how do I get rid of a squared? We've done this before. The square root is the antidote to square. Whatever you do to the left, you do to the right. So these two cancel each other out, and now I don't even need the parentheses anymore. On the left-hand side, I've got v plus 4. Everything else is gone. On the right-hand side, the square root of 48 is going to be plus or minus the square root of 48. Be careful. Plus or minus. Now we've got a little bit of a delay here. We've got to take care of this radical and simplify it. Without simplifying it, they're not going to be happy. So to simplify it, get the perfect square on the left and the leftover 3 on the right. 16 times 3 is 48, and this is a perfect square. Square root of 16 is 4, and here's our leftover. So what do I have? Let me clean this up a little bit. What I have over here is v plus 4 equals plus or minus 4 square root of 3. I got one more move and I found v. What do they want from us? They want v. V equals, that's what they want. Solve for v. So minus 4 on left, minus 4 on right, and here is, let me get this up there so it can be seen on when we do it together. Minus 4 on both sides, and on YouTube, v is equal to, as well, v is equal to negative 4 plus or minus the square root, negative 4 plus or minus 4 square root of 3. So there's two answers. Minus 4 plus 4 square root of 3, and minus 4 minus square root of minus 4 minus 4 square root of 3. There are two answers. The two answers in one. We've seen this many times. Okay, so there's that problem done. Now, here comes another short example that I can fit on this paper. I can definitely fit this on this paper. Number 4, a short example. What do you do with the 5th root of z to the 6th? Well, here's what you do. How do you simplify that? Well, you got to split it into 2 5th roots, a perfect 5th root and a leftover 5th root. What is the highest number beneath 6 that's divisible by 5? Answer is 5. So put z5 over here. And what's the leftover to get back to z6? Z. Z, 5 plus 1 is 6. Okay, what's the 5th root of z to the 5? The 5th root of z to the 5 is z itself. The two 5's cancel each other out. The two 5's cancel each other out, the root and the exponent. And what's the leftover that's not going away? It's the 5th root of z right over here. And here is our final answer to problem number 4. That's it for problem number 4. Okay, we have run out of space for things to be easily legible, so let's not push the envelope here. Let's get out of this video.